Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for today's program, because today on the show we have, you may have guessed it, Ralph Bond. He is our science and technology trends correspondent, joins us every Friday to talk about a number of stories, and it's always really fun, exciting. It's very uplifting stories, and I've been using social media more because with my limited hours, I decided let's just kill the last neurons I got firing. Let's just really smother them with a blanket. So I've been using social media more, and I promise, like I have seen, probably because of the algorithm, I'm not getting everything, but about 10 stories that Ralph has covered in the past year or two, I've seen in my feed recently. I've seen these stories get picked up by, probably bot farming accounts, but they're accounts that have hundreds of thousands of likes, hundreds of thousands of engagement. And ladies and gentlemen, I'm like, Ralph showed me this 6 months ago. So these stories, they're very interesting, I promise you, and they're also very timely. They're very futuristic, and that's what we love about it. It's definitely a lot of fun. So before we get started, computeramerica.com. That's where you'll find everything, including social media links. You'll also find past shows, future shows, show notes, articles, videos, anything and everything that we do here on Computer America you can find on our website. And primarily, you may want to pay attention to the show notes because Ralph does an amazing job of putting those together. And by the time that you hear this, the show notes will be up on the site. And yeah, these are just, links to everything, sources, videos. If there's something interesting that you can't watch on the video portion, check those out there. So with all that being said, let's go ahead and bring Ralph on and hey, just have a nice, relaxing show into this Friday. So once again, Ralph Bond, a longtime Computer America contributor, and now he has become our science and tech trends correspondent. Ralph, welcome back onto Computer America. How you been?
I'm great, Ben. It's wonderful to be back. And if you're new to the show, welcome. And let me explain what we do. Ben and I, each Friday, what we do is we highlight 4 recent articles that show us, and here's the key, no pun intended, key trends and developments in a bunch of stuff: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction technology, space research, physics. Wow, you name it. But here's the deal. Most important of all, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And I think we're just going to start with the first. And again, the show notes, super important. You can, of course, watch the video portion of the show, but if you're simply listening to us, you can go back after the fact and watch the videos and watch the video part. But Ralph, let's start with story number 1. And yeah, let's talk a little bit about the... we're just getting started with the show. Let's keep it nice and light. Quantum computers, always quantum machine learning. Just throw an extra quantum in there for the fun of it. Ralph, what's story number 1 about?
Yeah, story number 1 is definitely a mind melter, as everything to do with quantum mechanics, quantum machine learning, you name it. It still just blows my mind. But this first story comes from livescience.com. Headline: Scientists use quantum machine learning to create semiconductors for the first time, and the subhead is, and it could transform how chips are made. A little qualifier right up front. You and I, Ben, have talked about an instance where artificial intelligence was used to design a chip, and the team couldn't understand how the AI figured out what to do, but it worked. So that's a story. So a little caution on the first time part of this claim. But even so, it's a great story, really interesting. And another little qualifier, the date of this article is July 29. So the first claim may or may not still be accurate, and it has to do with a very specific part of the claim. But regardless, again, it's an interesting development. And in the show notes, as Ben was saying, if you're listening to us as a podcast, come out to computeramerica.com, get the show notes, because I have a link to the research paper. So we have the link to the article, and then we have a link to the team's research paper. If you're a super geek, you can dive in as deep as you want to, but let's get into this. Oh, and also check out another story we have as well. So let's get into this. Australia. If you think the outback is out of it when it comes to science and technology, think again. Australian researchers from the National Science Agency of Australia and the University of Melbourne have developed a pioneering method using quantum machine learning to model electrical resistance within microchips. That's the specificity of the first claim. It has to do with addressing the issue of electrical resistance. That means how fast electrons and so forth can travel on the highways, if you will, inside of a chip, okay? And then in the show notes, I have a little side tutorial inserted here. What is quantum machine learning? Real quick, let's do this to bring you back up to speed. Quantum machine learning refers to quantum algorithms designed to solve machine learning problems. These algorithms use quantum bits called qubits and quantum operations to process data in ways that classical computers can't easily replicate. That's the attraction. And the goal of using quantum machine learning in chip design is to improve speed, efficiency, and scalability of machine learning tasks by leveraging quantum mechanics. Now, in the show notes, I have an optional insert here to give you a refresh on qubits and quantum computing and so forth. You're welcome to come out and check that out. We're not going to go through that right now on air. But back into the story, from the introduction of the research paper, the team set the stage for the motivation behind their work. And it says, quote, "The rapid advancement of semiconductor technology has led to increasingly complex fabrication processes where device performance is highly sensitive to numerous process parameters, needless to say. However, collecting large, high-quality experimental data sets to model, understand, and optimize such processes remains challenging due to the cost and time constraints associated with semiconductor manufacturing." So, Ben, there's your motivation behind this research.
Yeah, it definitely seems like something that's going to happen and is happening and has been happening for a couple of years now, especially with machine learning, is, Ralph, everything's a sensor. Everything is a data point, and combining hundreds of thousands or millions of data points into, and being able to, put them into a model that can actually use all that. That's something where it looks like quantum computing is, going to hopefully, ideally, excel at. So exciting.
Yeah, actually, your comments kind of bring to mind something I learned in the very beginning of my career in high tech. I was working for a company, and they were teaching us how to program in the company's unique mini computer language. It was a company called Computer Automation. This is 1 billion years ago. And I remember the whole premise of if, then, else as an algorithm. If, then, else. And large language data sets can perform, and quantum computing even accelerates this, the whole infinitely fast, vastly touching data points, if then else. And that, for example, in the development of drugs and that sort of thing, right? It's just so amazing.
Imagine if there's if then else, but then there's if those, if let's say there's if then else, while and there's just a billion operators because it just understands language. It would be truly revolutionary.
Yeah, the parameters are endless, and the data set is endless, and the ability of the computers to do this work is endless now, it seems. Anyway, I digress a little bit, but that's fun. So going back to the story, and at the time of the announcement of this story, July 29, and they went on to say this is the first time quantum machine learning has been applied to semiconductor design, potentially transforming chip manufacturing. Again, take that with a grain of salt, because it literally is not true. I think it may be the first time it was applied to the issue of accelerating the movement of electrons through a chip. But anyway, the key benefit of this research has to do with chip performance enhancement. Modeling electrical resistance is crucial in chip design. It impacts speed, efficiency, and reliability. Again, I stress that's what I think they're talking about when they say a first. And going on here, quantum machine learning offers a way to improve precision and simplify complex calculations, which could make chip design faster and more scalable. And to conclude, the team's study marks a significant leap in combining artificial intelligence and quantum technology for practical applications in electronics. So it's part of a bigger story. It's one spoke in a giant wheel of AI as it is applied now to chip design. And it's a wonderful trend and area to watch, monitor, and learn from as we go on here.
Yeah, it's one of the strong suits of AI, and it's nice that it's not just being, like let's say you're trying to make a logo with AI, and you can, before you had to draw out a dozen different concept designs and then kind of refine. With AI, you can pop out a dozen in a snap of a finger. It takes almost no time. But that doesn't replace the need to, Ralph, really focus and, finish a design. AI can't really do that just yet. I think this is where they're kind of getting at with semiconductors is they can test hundreds of ideas in rapid succession and, using quantum, kind of machine learning, even accelerate that even more. And then they can kind of drill down, focus in, and make a good finished product. Yeah. So hopefully development time gets slashed, considerably, and that would be amazing.
Yeah. Pretty great stuff.
So there you go. Story number 1. And ladies and gentlemen, again, there's always more information in the article. Ralph does an amazing job of distilling the highlights. But if you want the research paper and you want more information, check out computeramerica.com. So that's story number 1. And story number 2, hey, this is also about AI, but also, something to kind of help AI because I'm sure, as Ralph can tell you, and anyone else out there who lives even remotely close to a data center, the ability for these things to scale. Well, Ralph, the ability for processors to scale, it's butting up against, what known physics of the very absolute tiny, now we're talking about angstrom processors that Intel is working on. Well, data centers have the opposite problem. They are scales of massiveness. They are how big can the buildings get? How much resources can we funnel into these buildings? And hey, the scale of the large, this is where story number 2 might be able to help a little bit.
Absolutely right. And I just absolutely love this next story. Got it from CBS News. And there's so many wonderful things about this. It makes me shake with excitement. Okay, so let's get into it. Headline: How used EV car batteries could help fuel the artificial intelligence boom. And by fuel the AI boom, they are referring, as Ben correctly pointed out, data centers that support artificial intelligence, right? We've got links to this. We've got several other links in the show. There's a great image in the show that shows a huge field of boxes with these repurposed electric vehicle batteries that have lived their life out as car batteries but have a new life, combined with solar panels, if you look at the lower right-hand corner of the image, to create an energy creation and storage solution for a large data center that's shown in the upper right-hand corner. It's just great. Love this concept. So anyway, in a field outside of Reno, Nevada, an outfit called Caruso Energy Systems, which is a developer of AI cloud computing platform, has paired rows of solar panels with stacks of used electric vehicle batteries sourced from recycling firm called Redwood Materials. And the whole purpose of this is to keep its data centers powered continuously, day and night. Wow. You gotta love this recycling idea.
Yeah, I've heard of a similar project. The one that really sticks in my mind was years and years and years ago. It was a gentleman who would go to secondhand thrift stores in Australia, and he would take laptop batteries, and I'm talking old ancient laptops. He would take the batteries out of them, Ralph, put them into an array on his wall, and he built his own home energy backup system. Now, of course,
Wow.
the flammability of that situation 10 years ago was probably amazing, but it seemed like he knew what he was doing, and he did in fact build essentially like a Tesla Powerwall of his own using old laptop batteries, because they can still hold a charge. They may not be good enough for their original purpose, but with 200-300 of them, old batteries are still good in a series, and that you still get something out of them. So it definitely harkens back to that story. But of course, this is a much more professional and larger scale. So
well, yeah, and to your point, Ben, imagine your concept that you just outlined, where this guy took these little batteries and combined them to make a makeshift Tesla wall battery. Just upscale this to a huge level, and that's what we're talking about. So back to the story, here's a bit about how the used EV car batteries are processed for this purpose. So Caruso Energy Systems is refurbishing and repurposing used EV car batteries through a strategic partnership with Redwood Materials, which is a leader in battery recycling and second life applications. And let's talk about this refurbishment and repurposing process. There's several steps. Step one, battery sourcing, getting the batteries. Redwood processes over 20 gigawatt hours of lithium-ion batteries annually, so a huge amount. Step two, second life evaluation. Many EV battery packs still retain most of their original capacity even after vehicle retirement, so they're not completely dead. These are assessed for functionality and safety before reuse in this process. And then step three, stationary storage conversion. Instead of immediate recycling, Redwood Materials repurposes these functional packs into stationary energy storage systems. This extends their useful life, the useful life of the batteries, and reduces waste. Of course, that's the win-win-win. I love this. And step four, these refurbished batteries are developed in Caruso's modular AI data centers, which they call Caruso Spark. That's their trademark name for these data centers, which include power, cooling, and graphics processing unit ready racks in a compact, portable format. And if some of the listeners might be going, why graphics processor unit? What? Remember, NVIDIA's architecture for their graphics processors happened to be very attractive and friendly to the kind of coding that you do for artificial intelligence. So that's why that's in there.
Yeah, there's a reason that they are almost a $5 trillion company, and it's NVIDIA powers AI. That's for sure.
Yeah. And the microgrid development they've come up with, the result of all this collaboration, repurposing these batteries, testing them and making sure they're good, and then putting them into storage packs, on and on and on. The result is a massive 12 megawatt and 63 megawatt hour microgrid, the largest second life battery deployment in the world, so they say, in Nevada, powering Caruso's AI infrastructure off grid with renewable energy. And by the way, remember that, for example, the 12 megawatts is a unit of power equal to 12 million watts. Wow. And here's it is truly incredible. And here's a little wrap up on the benefits of this approach that they've come up with. Again, this is Caruso and Redwood together as a team. Speed. This approach enables rapid development of AI data centers without waiting for traditional grid expansion, meaning the grid outside in the community. For example, I live in Hillsboro, Oregon. We have, I think we have at least 10 huge data centers with 15 more on the planning table, or it's the other way around. Regardless, they're tapping into the existing grid. What they're saying is get independence from the existing grid with renewable energy. That's wonderful. Sustainability extends battery life and reduces environmental impact. That's an obvious. Cost efficiency offers a lower cost alternative to new battery systems while maintaining high performance. And I love this part here in the article. It says this model exemplifies a circular energy economy. That's where you have the car battery finds a new life as the storage thing, and it just forms this wonderful circle. Once those car batteries that have been used for this purposes finally run their course, they can be recycled. I mean, that's what they mean by circular energy economy. I love this concept.
You kind of have that recycle logo, the kind of triangle with arrows.
Yeah,
and,
right.
It's not just reduce and recycle, but reuse is one of those one of those things.
Yeah.
So this is it.
Yeah, this is it. And again, repurposing before recycling, as we say here, to meet the growing demands of AI and clean energy infrastructure. And the redwood materials, this is an interesting data point in the article. Redwood materials, again, these are the guys that are experts in refurbishing old EV car batteries. They recently struck a partnership with General Motors to secure end-of-life battery packs from their dealerships, right? I mean, you gotta love it. According to Colin Campbell, Redwood's chief technology officer, these second life batteries typically retain about 80% of their capacity. Insufficient for vehicle use, but ideal for grid scale storage. So there you go. Bravo to this teamwork. What a great idea.
Yeah, it's great that these batteries aren't just, kind of thrown or scrapped and, tried to go back and make fresh new batteries, but to actually power this whole thing. And I love the idea that, these, I think the thing holding back the fact that we don't get more data centers, Ralph, is because of their sustainability. Like, it's one thing, it's like, oh, our community wants data centers, but, do we have the water? Do we have the electricity? Do we have the room for growth? And the fact that this could, be used to at least offset some of it, if not, be able to put them in more places, that will advance AI, for better, hopefully for better. So no, it makes a lot of sense. Love it because, like you said, just reusing things is part of that whole reduce, reuse, recycle, and batteries are going to be a big one because, Ralph, like, even with all of the news that's been happening in the past year, electric cars are not going anywhere. They are just getting more and more popular. And we need to find something to do with all of these batteries when, Ralph, it wasn't really a big deal when, 5% of all cars were electric. But what happens when, 30, 40, 50% of all cars are electric?
Right.
And what do you do with the economy of batteries after their life there? So
true. Yeah.
This is a great one. Perfect. And for everyone watching the video portion, I apologize. I just clicked on Redwood Materials near at the end. So check out their sites.
It's a cool site.
If you want to see those videos, and you could see everything Ralph's talking about right there.
Isn't that something? Wow.
It looks like something out of like The Sims or like a video game, but no, it's an amazing facility that they have put together there. So
bravo to those guys.
Absolutely. Story number 2. Story number 3. This one seems a little bit more low tech because we go from quantum computing to AI scalability. Let's talk about concrete. It's something, and it may not actually be concrete, but this is still super important because green sustainability, environmental consciousness. That's something that we definitely have a focus here with our segments with Ralph, which I really appreciate. And one of those is this, we've covered ideas of just sucking CO2 out of the air directly. We've talked about sequestering it in different ways, shooting it underground and whatnot. We've talked about all these different ways to make CO2, help out that particular problem of the environment. Well, story number 3 also looks to tackle that. And this is actually, could be, the end result could be even a useful product as well. So.
Absolutely. So we'll set up the story here, kind of set the stage, as it were, for this story, which comes from technologynetworks.com. The headline is Carbon Negative Building Material Made from Seawater and CO2. That headline I couldn't resist. And this is indicative of the technology work, research being done for the building industry. Ben, as you alluded to, if you look at the building industry, there's things like energy absorbing paint that can be like a solar panel, or windows that can be solar panels, construction materials, concretes, and so forth and so on that have the
metamaterials. I would say of like all the different different sectors that you cover, Ralph. I think metamaterials is really coming into its own in the past 5 years.
Exactly. And the takeaway I want to leave before we dive into the story is, if you think construction industry is boring and low tech, think again. From the design of these buildings with building information modeling all the way through these materials, it's a fascinating field. So with all that hoo-ha set up here, let's get into the story. Researchers at Northwestern University in Evanston, Illinois, have developed a carbon negative building material using seawater, electricity, and injected CO2. Okay, so how does this work? Using an electrochemical process, seawater is split using renewable electricity, that is, the process called electrolysis, producing mineral deposits like calcium carbonate and magnesium hydroxide. Now, these minerals trap CO2 up to 50% of their weight. So if the material weighs a pound, half pound of carbon dioxide is absorbed, right? Isn't that cool? But here's the fun part. And we've seen this before, Ben, in stories long ago about taking inspiration from nature. And this is a really good example. This whole design, this whole technology that they've come up with mimics how mollusks form shells. And a little side note, I will go through this because it's so interesting. Side note, mollusks build their shells using calcium carbonate secreted by a tissue called the mantle. The process involves precise crystal formation, either calcite or agranite, arranged in complex microstructures that give shells their strength and beauty. Studying this process, what mollusks can do, helps scientists understand how living organisms create hard materials, which has implications for bone growth, coral reefs, and even synthetic materials, which is applicable to this story. So back to the story, how the Northwestern University team is creating a building material by adjusting voltage, current, and CO2 flow. Researchers can control the texture and density of the resulting building material. And to wrap it up here, applications, you can replace sand in concrete or be used in plasters, paints, and magnesium-based cement. There's your concrete. Offers a scalable method to reduce emissions in the construction industry, aligning with the net zero goals for 2050. And ongoing work aims to refine mineralization control and scale up production. So again, friends, we talk about trends. Most of our stories that Ben and I do each Friday are twinkle in the eye, early research. This is a good example. They're saying their next level of work is to refine the mineralization control of the process and to see if they can scale it up to a practical deployable level.
Yep. And just glancing at the article, you can even, dig out little, little nuggets like this one here, this quote from the doctor working on this, Ralph, saying that the material that they're working with and trying to utilize, which is, again, turning something that is waste into a useful product, which is, again, what we have here. This is a byproduct of green hydrogen production. So turning what was once trash from an already green process and taking some of the trash and turning it into an even further green process just makes it all the more attractive for, it's really first intended purpose and now a second byproduct, which is just a win-win.
You bet.
It's perfect. So story number 3, it's great. I don't know how you build a house out of this stuff. I could probably build nachos before I could build houses out of this, but no, like you said, it replaces sand. I'm sure it grinds up real nice. So there you go. Very, very cool. Story number 3. Story number 4, let's go ahead and talk a little bit about this. This is AI, but more so, it's medical, and Ralph's going to get into this, but story number 4, it, could be good news for people that are looking for an early diagnosis of cancer.
Yeah, it sure is. This is, and Ben, by the way, to share with the audience, what Ben and I like to do usually is end the 4 articles we highlight with something from medical technology, because this is very near and dear to my heart, no pun intended. This comes from medicalexpress.com. Headline: researchers develop a biosensor based on light and artificial intelligence for early diagnosis of cancer. Wow. And in the show notes, once again, we have the research paper as well as the original article, links and so on if you want to dive really deep into this. And I'm going to look, folks, this is very geeky medical science stuff. Does Ralph understand this? No. But I'll try to give you the essential nuggets of the story so that you can go back. If you are a smart medical person, you can understand this, or a scientist, go and look at that research paper and it'll all make sense to you. But I'm give you the highlights.
from a layman, they include pictures for simpletons like me, and you can see they have here the ramen laser that's measuring the ramen here, and they got your gut where the ramen goes. It's all pretty straightforward, Ralph. I don't know what you're talking about.
Sure, you bet. So, but with that qualifier, that truth in lending statement up front about my ability to understand this, let's dive into it. A research team from the Advanced Bio and Healthcare Materials Research Division at the South Korea, of course, Korea Institute of Materials Science has developed an optical biosensor capable of detecting trace amounts of cancer cell DNA in the bloodstream with high sensitivity, enabling early cancer diagnosis. And that first paragraph is so loaded, but we're going to try to lay it out here. I worked these notes over and over to try to get this as digestible as possible. But first, let's talk about what conventional liquid biopsy techniques used today involve. And then that shows how it will show how this development is a radical departure from that they think is very hopeful. So compared to conventional liquid biopsy techniques, this new optical biosensor technology offers superior sensitivity and specificity. And its standout feature lies in its ability to diagnose cancer early using only light signals and AI-based analysis without the need for complex testing procedures. For example, with all my skin cancer stuff, they take a little sample of my tissue, it's sent to the lab, they do all their magic and stuff like that. Or there's liquid biopsy techniques involving your blood and so on and so forth. Well, this is a brand new, exciting, and much more efficient technique they've come up for early diagnosis. But the key here is looking for trace amounts of cancer cell DNA. So this is mind-meltingly geeky, but anyway, pretty cool stuff, Ben.
It seems like the stuff that they're tracking down and trying to isolate is going to be like so minute in your bloodstream and so minute in these samples, but they're able to still pick it up and detect it. And that's really amazing.
It is truly, and you're right. That's what's part of the miracle of this research. Little side note, though, conventional liquid biopsy techniques, today's liquid biopsy is a minimally invasive method that detects cancer-related biomarkers in blood, offering a powerful alternative to traditional tissue biopsies. So you have tissue biopsies, then you have these liquid biopsy techniques, and then now this new technique, the Korean optical biosensor. So let's go through some of the key highlights of this new Korean optical biosensor technology. The new technology combines plasmonic materials. Okay, these are materials which amplify light signals, and with artificial intelligence to detect DNA methylation, which is an early marker of cancer. And my brain went, what? DNA methylation? I know what DNA is, but methylation? What's that? Well, let's get into that real quick here. DNA methylation is a biochemical process where a methyl group, which is one carbon atom bonded to 3 hydrogen atoms, is added to the DNA molecule. And I'm still going, what? But wait, abnormal methylation patterns are linked to diseases like cancer, which is applicable to this story, heart disease, and immune dysfunction. So it's this anomaly in the DNA of the cancer cells that they're looking for to detect early that there's something wrong. Now, going back to this technology, the sensitivity, this will blow your mind. The sensitivity of the new optical biosensor. Well, it detects methylated DNA at concentrations as low as 25 femtograms per milliliter. Now, that means about 1/25,000th of a sugar grain in a drop of water. What?
That is so minute that, I don't think I've ever seen anything that's sensitive when it comes to, testing. And again, it's one thing, water and sugar, but like actual blood and all the different chemicals and trace chemicals and everything in blood, and they're still able to pick up cancer. That is amazing.
The cancer, these to be able to detect these methylated DNA markers, they call it. And again, a femtogram. And I said, what's a femtogram? Well, that's pretty interesting. It's 1/4,000,000th of a gram. What? 1/4,000,000th. So we're talking their accuracy of 25 femtograms, 25 quadrillionths of a gram. What? Wow.
It's crazy.
Crazy. So more about the test and why this is so exciting. It's speed and simplicity. It requires only 100 microliters, of blood, and delivers results in 20 minutes without complex processing. Now, here's how the test works. A standard blood draw is performed. We've all had that done. No surprise there. The sample is processed to isolate plasma where tumor-derived materials are found. That's the methylated DNA fragments. Advanced sequencing or molecular assays are used to detect and analyze cancer-specific markers. How about accuracy? This team achieved 99% accuracy in identifying colorectal cancer across all stages in a study involving 60 patients. Again, this is early research, folks, early. And the applications suitable for hospitals, home diagnostic kits, and point-of-care testing. According to the Korean research team, their plans for this technology include expanding to address autoimmune and neurological diseases, so going beyond cancer. And this innovation could redefine how early-stage cancers are diagnosed, making screening faster, cheaper, and more accessible. If this doesn't end your Friday on an up note, I give up. I love it.
Yeah, I can't imagine it seems like the apparent accuracy, the low cost of it, the timeliness of it, the fact that it can be, it could be at home kit, it could be, in a lab. There's so many things, like there doesn't seem to be a lot of hurdles other than just, hey, we need to, first of all, the study size seems a little small, so, bigger trial studies. But other than that, like, this seems to hit everything you need for accurate, quick, good diagnosis. And of course, as everyone knows, early diagnosis leads to much better outcomes. So
yes.
This could save a lot of lives, Ralph.
Boy, yeah.
I definitely love that. So that's story number 4. Ladies and gentlemen, you may notice that there are more stories even beyond story number 4. But story number 4 is, kind of the last one that we do here on the show. Try to keep the show a bit more concise for easy listening. But, because, hey, who doesn't think easy listening and Computer America in the same thought? But you may notice there are more stories in the show notes, and these are titled Honorable Mentions, where honorable mentions are stories that are just as good. They are from the same pool that Ralph would, normally get stories from, but we just don't have time. So Ralph is going to go ahead, give you guys the headlines, and you can find out more if you like in the show notes at computeramerica.com. And yeah, just learn about some more amazing stories, because it's not just 4. There are many stories out there, many people doing a lot of great research, and you should be aware of it. So Ralph, let's give them the headline.
Oh, yeah. Well, what we're going to do is give you 4 honorable mentions to complement the 4 major stories we just did. And the first one comes from WPI News website. Headline, Worcester Polytechnic Institute researchers develop cleaner, scalable process to recycle lithium-ion batteries. And Ben, of course, there's so much research all over the world trying to find new and better ways to recycle lithium-ion batteries. And this is a good example of that trend. Check it out. It's pretty interesting stuff. The next one, I'm not sure how to pronounce this. It's a lowercase p and then all caps pFIBRE.
pFIBRE?
pFIBRE. Let's go with that. That's the name of the company. pFIBRE launches scalable, biodegradable films to replace single-use plastics. This comes from the packhub.com. And again, Ben, you and I have seen so many research efforts to how can we replace plastic grocery bags. Like yesterday, I went to the supermarket, bought a couple of zucchini, put them in the little thin plastic bag they give you. Well, wouldn't it be great if you had a biodegradable version of that, and so on and so forth? That's part of what this research trend is all about. Check that article out. The next one is from futurism.com, a wonderful website. Headline, scientists create living plastic alternative, and it's edible too. A great compliment to the story we just highlighted here. But now we're talking about, and of course, guess what? No surprise, based on mushrooms. You and I have seen time and time again, fabric made of mushrooms, this made of mushrooms, this and the mushrooms are an amazing organism that are a treasure trove of potential. And here we have somebody who's created living plastic alternative, and it's edible too. Gotta love it. So I could take that bag someday from the supermarket and have a snack.
Yeah, exactly. It's the most divisive part of the story is whether or not you like mushrooms or not. So
Yeah. Well, they can put a candy flavor on it or something.
There you go.
The last one comes from good old MIT news website. Always a treasure chest of wonders. The headline here is Nth Cycle, that's NTH Cycle, is bringing critical metals refining to the U.S. The company is already producing nickel and cobalt from battery scrap in Ohio. Wow, there's so much going on in that story, but it's another example of bringing more stuff here to the United States that heretofore we're relying on China and elsewhere for these kinds of things. Now we're developing our own technology and repurposing batteries. I love that too. Great story, and it's a great one to end our show on.
Absolutely. Yeah. It's, again, kind of, I think it was story number 2 with the batteries. Just, hey, the end of life of batteries doesn't mean the end of life of, the materials within the batteries. So,
right.
Ladies and gentlemen, the music in the background means that we are wrapping up. And again, if you want to find out anything that we talked about here today, computeramerica.com. We have show notes. We have at the top, we have Ralph Bond, a whole segment with his most recent segment as well as his past segments. So you can find us on YouTube and you can find everything on social media. Go ahead, go there and check it out. Ralph, I want to thank you so much for joining us here and doing these stories. As always, they are amazing. And people, I think for a Friday, I can't think of a better type of show to really give the folks. So with that being said, ladies and gentlemen, until next time, have a great weekend. Do something fun. We'll catch you here, computeramerica.com one last time. And everyone, do something fun. We'll see you next time. Have a good one. Bye, everyone.